In this section, we're going to talk about sectors of circles, which means parts of a circle. Before we can really talk about the parts of the circle, let's make sure we understand the terminology around the actual angles and arcs a circle is comprised of. So in a circle, we have something called a minor arc and a major arc. So the minor arc is less than 180 degrees, and a major arc is greater than 180. Remember that in a circle, if I go all the way around, the total measure of degrees will be 360. So if you take a look at this picture here, what it's showing you is that this arc here from A to B is 50 degrees, and that minor arc corresponds with the central angle of 50 degrees. Notice that the central angle is a measure of an angle that's between two radii. So I see these two radiuses, or radii. Between them, that central angle is that 50 degrees. If I look at the major arc, ADB, this big arc here, to find it, I can do 360 minus 50. Here's that 310. So this big major is 310, the minor is 50. Now, if a full circle is 360 degrees, based on the previous video, we're able to find out that the full circle can also be thought of as 2 pi radians, which means that if I go halfway across 180 degrees, that's equivalent to pi radians. And that's something we can use when we convert between degrees and radians. It also can be useful when trying to find the area of a sector or the arc length of a sector. So a sector is part of a circle. In this picture on the right, notice that the shaded sector is this arc A to B and that whole region of APB with that radius R marked. So to find the area of a sector, think about it as saying, I have the full circle, but I only want a fraction of it. There's only a fraction that I care about. If this was a pizza, and let's say your pizza was in 16 slices, and you only ate 3 of those slices, you're saying the fraction of the pizza that mattered to you were those 3 out of the entirety of 16. So we can think about this as saying fraction that you care about, or the shaded region, times the entire area. And to find that fraction, we typically think about that size of the angle. Now this one's not marked, but we can talk about what it means with these symbols over here. Let's suppose they told you the central angle in terms of n degrees. To find the area of the sector, you would do n divided by 360, so part over whole, times pi r squared, times the area of the circle. If it was in radians, do the same thing, but do n over 2 pi, because again, that full circle can be thought of to be 2 pi radians. Now, those two equations are the multiplication method. If you prefer ratios, you can also use a ratio. The sector area, in our case, that would be the unknown, that would be the a or the x. The sector area divided by the entirety of the circle's area equals the central angle over 360. Or in terms of radians, that unknown area over area of the circle equals central angle in radians over 2 pi. And we have something similar for arc length. So arc length is like the crust of the pizza, not the inside toppings and filling, just the crust. And we solve it the same way. Fraction that you care about times the circumference. So notice up here, I have n over 360 times 2 pi r. And because we can think of 2 pi r as pi times diameter, pi d, this equation here is equivalent. If I'm using radians, n over 2 pi times 2 pi r. And if we simplify that, you can think of it as n over 2 pi times pi diameter. And you could also cancel out the 2 pi's if you like, and think about it as n times r. All those equations are equivalent just by manipulating the variables. If you prefer ratios, the sector arc length, that's your unknown. So arc length over entire circumference, 2 pi r, equals central angle over 360. Again, that's only if you're given it in degrees. If that angle measure n was given to you in radians, do the exact same thing, but do n over 2 pi, whatever that central angle is over 2 pi. And whenever you're solving a ratio, you'd probably cross multiply and then solve for the unknown. In this question, we've been asked to find the arc length of AB and the area of sector APB. We know that the radius is 8 centimeters and that the central angle is 60 degrees. So I'm going to do this two ways. I'm going to first solve it using straight across multiplication, and then I'm going to go ahead and show it using ratio method, because both answers will get you the same thing in the end. So I'm going to go after arc length first. So I'm going to do arc length. Okay, so for the straight across method, I see that my central angle is 60 degrees. So for the fraction that I care about, I'm doing 60 divided by 360. Again, 360 is for the full circle, 60 is just for the sector I'm caring about. Times 2 pi r, because arc length is this region here that I'm right now outlining in blue. So it's what fraction of the circumference, what fraction of this pizza do I want to look at? What part of the crust? So times 2 pi r, and again, we know that r is 8. And I'm going to go ahead and put this over 1 so I remember how to multiply my fractions. I'm going to go ahead and simplify this. All right, so I had 60 over 360, and I remember that I can divide top and bottom by 10, so it's really 6 over 36. I can then divide both of those by 6 to get 1 over 6. So that means I have 16 over 6, but both of those are even numbers. 16 divided by 2 gets me 8, and 6 divided by 2 gets me 3. So I have 8 pi on the top and 3 in the bottom. So 8 pi over 3 centimeters. So that's the multiplication method. I can do the same thing using ratio method. So I have 60 over 360 equals our unknown arc length, L, over 2 pi r. Now we already know 60 over 360 is the same thing as 1 over 6. And on this side, L over 16 pi. To solve for L, I have to cross multiply, or at the very least, multiply this to the other side. Now, if you're comfortable recognizing that all you have to do is multiply this to the left-hand side, you are welcome to do so. If you don't quite understand that, you can also use cross multiplication. You'll get the same answer in the end. For example, what I can say is 6L equals 16 pi. Again, 6 times L, 16 pi times 1. I then come through and divide by 6. So I have L equals 16 pi over 6. And that's what I mean by saying that if I just multiplied this to the other side, I would have had 16 pi over 6. Go ahead and simplify it. Divide them both by 2 here, and I get out 8 pi over 3 centimeters. So again, that value is for my arc length. Let me go ahead and draw a separation here. Let's now go ahead and find the area. So now looking at area. So I'm going to start the same way. The fraction that I care about is 60 over 360 times the entirety of the circle. In terms of area though, pi r squared. Now again, the thing I'm trying to find right now is this section up here. All of this stuff, that's what I'm trying to find. So 60 over 360 times pi r squared. So pi 8 squared. Remember, 60 over 360 is just 1/6. So this pizza slice is 1/6 of the entire pizza. So 1/6 times 64 pi. I'm going to put that over 1 so remember where that separation is. And I got the 64 by doing 8 squared. And these are all equal signs. Okay, so now I'm going to go ahead and write it as 64 pi over 6. And I say, what do they have in common? Well, they can both be divided by 2. 64 divided by 2, so this top one divided by 2 gets me 32. This bottom one divided by 2 gets me 3. So my end answer is 32 pi over 3. and my units are centimeters squared. I can do the same thing using ratio method. So my ratio would be 60 over 360 equals the area of the sector over pi r squared. So part over whole equals part over whole. Remember that 60 over 360, that's just 1/6, equals a over 64 pi. Now again, at this step, you can go ahead and cross multiply, or you can recognize that if I simply multiply this to the other side, I'll have the fraction that I'm looking for. Same answer in the end, it's up to you how you solve it. And I will show it using cross multiplication. So I'm going to show 6a equals 64 pi. Again, crossing along here and along there. Divide both sides by 6. So a equals 64 pi over 6. And if I divide the top by 2 and the bottom by 2, I am getting out 32 pi over 3 centimeters squared. So again, remember what I just did. I said divide this by 2 to get 32, divide that by 2 to get 3. And that's how I got this right here. So these are the sector areas. These are the sector arc lengths. In this next question, we've been given circle Z with central angle of 40 degrees, and this arc length XY is 4.19 inches. And we've been asked to solve all the missing parts. This includes finding the radius, the circumference, the area of the sector, and the area of the entire circle. So I'm going to start by finding the entire circumference. And I'm going to do this using ratio method. So I'm going to do 40 over 360 equals 4.19 over x. Or I could call it c, your choice. Actually, you know what? I will change it to c. That way I've been consistent. C for circumference. Again, call it anything you want, it doesn't matter. I'm going to go ahead and simplify this fraction. 40 divided by 360 is 1/9. If I divide them by 10, it's 4 over 36. If I divide them by 4, it's 1 over 9. So I have 1 over 9 equals 4.19 over c. I'm going to go ahead and cross multiply. 1 times c is c. I now have to do 9 times 4.19. 9 times 4.19, and I get out 37.71. So 37.71 inches. So I've now found the circumference. Let's go ahead and find radius. I can find the radius by either using this portion here or by using this one here. I'm going to do it off of this one here. Remember that we know that circumference is 2 pi times the radius. So 37.71 equals 2 pi r. So 37.71 equals 2 pi r. If my job is to get the radius by itself, I'm going to have to go ahead and divide both sides by 2 pi. So r will be equal to this, which is approximately, now I've got to put in a calculator and see what I approximately get. So 37.71, actually I'm going to put this in fraction version, 37.71 over 2 pi, and that's very close to the value 6. Notice that the third decimal place, the thousandths, is a 1. That's so far out, we're just going to round this to 6. 6.001 is just going to become 6 for our purposes. So r is approximately 6 inches. Let's go ahead and find area of this entire figure. So remember that area equals pi r squared. r is going to be 6. So this equals pi times 6 squared, which equals 36 pi. Normally, I would say leave it there, but because of these other decimals, let's go ahead and give a decimal version also. So 36 pi is 113.097. This 7 is going to cause that to round up. We're going to become 113.1. So I can say area is 36 pi, but this value is also approximately 113.1, and our units are inches squared. So inches squared, inches squared. And that is the area of circle Z. So I'm going to make a little note. This here is circle Z. We have one left to do, and that's the area of the sector. So again, now that we know what this radius is, finding that area is not hard. We can also use the ratio method if you prefer. It does not matter. So I'm going to go ahead and come down to this space right here. I'm going to separate it for us. So I'm going to say area of that sector XZY. So A for area, that's my sector. And this is going to equal the fraction that I care about. So 40 over 360 times pi r squared. Now again, we know our r is 6. So 40 over 360 times r squared, so 6 squared. Now again, this pi r squared, it's the same as this value right here. All the way down, we're really dealing with 36 pi. Let's go ahead and just plug that in. Again, area of the circle is here. Area of our circle is 36 pi. Let me switch colors so you can see it's the same thing. 36 pi. Let's go ahead and simplify this. We already know that 40 over 360 is just 1 over 9. So I have 1 over 9 times 36 pi over 1. So this becomes 36 pi over 9. And we know what 36 divided by 9 is, just 4. So this area of sector XZY is going to be 4 pi. And again, normally I would leave it like that. But because of all these other decimals, let's go ahead and give a decimal approximation also. 12.57. So area is approximately 12.57, and our units are inches squared. So we have circumference, we have radius, we have area of circle Z, we have area of the arc XZY. And again, this stuff, XZY, that's this inside stuff here. Our radius is right along here. Our circumference is the big thing, and the area of our circle is everything going on here. So it's all of this stuff and including this stuff here. So that's the area of everything. In question 3, I have circle B with radius 10. I have points A and C, and I'm trying to find arc length AC and sector area ABC. I know that the central angle is pi over 2, meaning that this time they've given me a value in radians. So I'm going to go ahead and I can either use, again, multiplication method or ratio method. It doesn't matter. I'm going to go ahead and do this using ratio method. So I'm going to show that, let me go after arc length first. I'm going to show that I have arc length L over 2 pi r. So 2 pi, and this time r is 10, equals pi over 2 divided by 2 pi. Now I can either simplify this first or I can multiply. That will be entirely your choice. I'm going to go ahead and multiply. So I'm going to have 2 pi L equals pi over 2 times 2 pi times 10. Now I did this for a particular reason. As you look at this, you'll notice that these 2's cancel out. And let's say I want to go ahead now and get L by itself. Divide both sides by 2 pi. So on the left-hand side, I have arc length L is equal to, let's see what we have left. I have pi times 10, so 10 times pi, and in the bottom, I now just have 2 pi. Well, some of that stuff cancels out. These pi's go away, and 10 divided by 2 is 5, so my arc length is 5 pi, and the units are feet. So again, that was using ratio method. Alternatively, I could have actually simplified this up here and then gone forward from there. Your choice. Now let's go ahead and go after the area. So the area of the sector. And this time I'll use the other method. So I'm going to have pi over 2 divided by 2 pi times, now again, right now this is the fraction that I care about, times the entire area, which is pi r squared. So times pi r squared, I'm going to write that as over 1. Okay, so this part here, remember, this says pi over 2 divided by 2 pi. So let me make a note of that. This says pi over 2 divided by 2 pi over 1 times 100 pi. Remember, dividing by a fraction is the same thing as multiplying by its reciprocal. So the bottom of this is really 2 pi. So pi over 2 times 2 pi times 100 pi over 1. Let me separate this. So again, notice what I just did. This 2 pi here is this 2 pi right there, because multiplying by the reciprocal puts that thing in the bottom. And also notice then that these pi's can cancel out. Those pi's are gone because pi divided by pi is just 1. In the bottom, I have 4. In the top, I have 100. And again, you can see this. I have 100 pi divided by this 4, which means all I have left, this area, is 25 pi. And my units are feet squared. So this side I use ratio method, this side I use straight across multiplication method. It is up to you which way you do it. It does not matter. In this next question, we've been asked to find the area and perimeter of the shaded region. Observe that this is a rectangle. I have 4 right angles, the definition of a rectangle. Notice that this one side is 6 and this side is 13. So notice that if I want to find the area of this, I can take the area of the rectangle and then subtract out these parts of the circle. Notice that because it's a rectangle, that is 6, this will also be 6, this will be 13. These two semicircles, if I put them together, I get a full circle. So here's what I can do. I can think of this as shape decomposition. So area of shaded equals area of rectangle minus area of circle. So rectangle, take away circle. Well, area of the rectangle, that's going to be 6 times 13. Remember, area of a rectangle is length times width, or you can think of it as base times height. So 6 and 13, that's the area of the rectangle. Minus area of the circle. Remember, area of a circle is pi r squared. 6 is the diameter. R is 3. So again, these here, these are 3's for the radius. So pi times 3 squared. So coming through here, I have 6 times 13 to get 78. So I have 78 minus, well, 3 squared is 9. So I have 78 minus 9 pi. And this question didn't give us any units, so we're going to say units squared. This here is a perfectly valid answer. So 78 minus 9 pi units squared. However, if you want to see a decimal, we can say this is approximately 78 minus 9 pi. We have 49.73. So it's roughly 49.73 units squared. That is for area. For perimeter, we have something similar. Notice that these 13s are those horizontal borders. We now need to have that portion of the circle. Now again, these two circles form a full circle, so I just need to take circumference of that entire circle. So to say perimeter, or P, of shaded, slide this up, what we need to do is 13 plus 13 plus 2 pi r. And r, again, is 3. So again, this here are those sides of the rectangle. This here matches the curves of the arc. So I have 26 plus 6 pi, and this would just be in regular units. And I can go ahead and give us an estimate. 26 plus 6 pi is roughly 44.85. So this is approximately 44.85 units. And this is referring to perimeter. In this question, we've been given a right triangle. It's actually an isosceles triangle, 7 by 7, and attached to it a semicircle, exactly halfway across of the circle, lined up with that side of 7 meters. We're tasked with finding perimeter and area. So first thing to note is what the radius is. 7 is a diameter. So for radius, again, this portion right here, we're looking at using 3.5. I'd say r equals 3.5. So I'm going to go after perimeter first. So perimeter. So what I need the area of the perimeter, sorry. I need the arc length of that semicircle. And notice exactly half of a circle. So I might say it's half of the circle. This is half of the circle's perimeter. Plus 7 plus 7 plus c. I'm going to call that c there. I've got to find that value first. So before I do the rest of this, let's just go ahead and find that right now. Remember, what I have is this triangle here, 7 and 7. Now, to find c, I can use Pythagorean theorem, or I can recognize that I have an isosceles right triangle. And so what I'm going to have over here, well, that's going to be 7 root 2. But we can go ahead and prove it anyway. So I'm going to have 7 squared plus 7 squared equals c squared. So I have 49 plus 49 equals c squared. I'm going to go ahead and take the square root of both sides. And again, I'm only taking the positive version. So c equals the square root of 98. Remember that the square root of 98 was 2 times 49. And we know what 49 square root is, 7. So c equals 7 root 2. But again, we already knew that because of what we're doing prior with 45, 45, 90 triangles. Either way, let's go ahead and continue from there. So I'm just going to go ahead and draw an arrow. So we have 1/2 of that perimeter of the circle, that circumference basically. So what I'm looking at there is going to be 1/2 times 2 times pi times r, which is 3.5, plus 7 plus 7 plus 7 root 2. Well, half of 2 is 1, so I'm left with 3.5 pi plus 14 plus 7 root 2. So that's going to be my perimeter. All of that stuff in meters. If you want a decimal, let's go ahead and add that stuff together. So I have 3.5 pi plus 14 plus 7 root 2. That's approximately 34.9. So again, P is approximately 34.9 meters. And let's go ahead and go after area. So area is going to be 1/2 the area of that circle plus area of that triangle. Now remember, triangle's area is 1/2 base times height. So I have 1/2, and let me go ahead and put the stuff in for area of a circle. 1/2 pi times 3.5 squared plus 1/2 times 7 times 7. Remember, base times height is where they meet the right angle. 7 and 7. So coming through here, I have 3.5 squared. That's 49 over 4 or 12.25. Either way. I'm going to write this as 12.25 pi over 2 plus 49 over 2. And now we can go ahead and keep simplifying that. This divided by 2 is 6.125. So over here I have 6.125 pi plus, and 49 divided by 2, that's your 24.5. So plus 24.5. So that would be the exact form. And again, this here is going to be meters squared. But if I want to get a decimal out for everything, just plug it on in. So I'm going to have 24.5 plus 6.125 times pi. And that's roughly 43.74. So approximately 43.74 meters squared, and that is for area of this entire figure. And so again, that's called shape decomposition because I've broken down this figure into circles and triangles. Do the same thing with our previous question, which had rectangles. The point of it is to figure out how these shapes are fitting together. For the stuff we're looking at right now, the shapes don't have any overhanging edges. Everything will match up perfectly.